Welcome to ASCII Geek.
Hey, if we haven't met already, I'm the digital avatar of ASCII Geek,
where we build your next advantage with tomorrow's technology. And today, one of our experts is stepping in to show our latest breakthrough. Enjoy and happy learning.
All right. Developers deploying autonomous coding assistants expect a productivity boost. Instead, many find their organizational API quotas rapidly exhausted, running up massive bills and bringing entire engineering pipelines to a dead halt. The cause is often invisible. Modern AI developer tools execute constant background operations, scanning your architecture, parsing hundreds of files, and quietly gathering context while you type. By default, every single one of these automated requests is routed to a single monolithic Anthropic server endpoint. This high-frequency, unseen data transmission quickly overloads the connection. The server responds with an HTTP 429 too many requests error, hard stopping your active session. Because API limits are calculated at the organizational level rather than per individual, one developer running an aggressive agentic workflow consumes the shared pool, locking out the entire engineering team. When all traffic is forced through one endpoint, a tool built to accelerate coding becomes the exact bottleneck that blocks your workflow. Anthropic's rate-limiting token bucket algorithm relies on two metrics. The first is requests per minute, or RPM. Agentic tools rarely hit this ceiling. The true bottleneck is input tokens per minute, or ITPM. Deep context reads demand massive prompts, instantly draining it, triggering lockouts. Anthropic also enforces acceleration limits. If your request volume spikes from 0 to a high rate immediately, the infrastructure rejects the traffic to protect server stability, even if you have plenty of absolute quota left. Sending simple background file scans to a premium high-reasoning model means you are paying top-tier token prices for basic indexing tasks. These API rate limits and token costs are the direct result of client-to-vendor coupling. If you can intercept the requests, you can rewrite the rules. The solution is Claude Code Router, an open-source, local proxy middleware built to sit directly between your IDE and the external internet. As illustrated in this network map, the router binds directly to port 3456 on your local host, physically breaking the standard outbound connection path. It intercepts every outbound request generated by the Anthropic Agent SDK before that data ever reaches the external network boundary. The local Claude client operates under complete deception. It continues to function normally because the proxy feeds it the exact Anthropic formatted responses it expects to see. Under the hood, the proxy dynamically translates the Anthropic payload into the specific REST API format required by whichever external provider you choose to target. Adding this abstraction layer strips away the vendor lock-in, converting Claude Code into a provider-agnostic universal LLM client. This visual represents the router's config.json file. It acts as the switchboard, reading the specific task types generated by your IDE and mapping them to different physical routing pathways. Take the background key. The proxy isolates silent file scanning and routine context gathering tasks as they happen. It then shunts these background operations exclusively to a free local Ollama instance. The hidden token drain stops immediately. Next is the think key, which identifies high-complexity plan mode operations that require severe logical rigor. The proxy switch ensures these specific requests are sent straight to specialized reasoning models like DeepSeek. You can also configure a long context threshold variable. This triggers automatically whenever a single request payload exceeds a defined limit, such as 60,000 tokens. The junction intercepts these massive, heavy payloads and reroutes them to models with inherently larger context capacities, like Gemini. Task-based routing ensures you pay premium API rates exclusively for premium reasoning, while offloading the heavy lifting to specialized or free local engines. The proxy handles security through environment variable interpolation. It reads your API keys locally and dynamically injects them into the headers right as the traffic routes out, keeping them out of your raw configuration files. For engineers needing exact control, the custom router feature lets you write your own JavaScript fallback logic to magic rate limit resilience directly. If your primary cloud provider throws a 429 error, the proxy intercepts that failure before your IDE sees it and silently reroutes the exact same payload to a secondary provider. Looking at this interface, the Claude UI on the left still displays the default model name. The proxy log on the right is your actual source of truth, tracking every real-time provider switch and header rewrite as it happens. This failover architecture maintains continuous pipeline operation, keeping your workflow active even when major third-party cloud aggregators experience regional outages. Optimizing token costs is highly efficient, but proxy middleware solves a much stricter operational requirement: data sovereignty. This map shows why pushing proprietary code to the external internet creates severe compliance risks. Watch a packet containing architecture attempt to transmit as a background task. The proxy switch forcibly captures it, routing downward to the local Ollama node. The request is processed entirely within the shielded local network. Your code never breaches the external internet boundary. By enforcing local routing for all context parsing, Claude Code Router establishes a zero-trust perimeter. Agentic coding becomes fully viable for strictly regulated enterprise environments. To deploy the router, you need Node.js, the Claude Code package, and a working backend like Ollama or OpenRouter. Simply execute the global npm installation command to instantly compile the proxy directly into your secure local development environment. Launching the proxy and the client requires only a single start command. The router takes over, automatically configuring all local environment variables in the background. Check the description below this video to copy and paste the baseline JSON configuration template and get your multimodal routing live today. Single vendor dependency is an architectural choice. Install the router, define your fallback logic, and take absolute control over your token economics and data sovereignty.
All right, that's the update from the lab for today. I hope you learned something new. Head over to ASCIIgeek.com